Okay, let's look at the next question. Talks about an airplane traveling east and another airplane traveling north. And so if we have one traveling east and one traveling north, they're traveling at different speeds. Um, they left at the airport at the same time. Then how fast is the rate of their distance apart increasing? So this distance, that's what we're kind of wondering. And I think that everybody would agree that, whoop, don't want to do that. What happened to my blue marker? There it goes. If we take, wow, really struggling here. Can I like click on that? There we go. Move. Oh, it's just gonna grab that one guy. Whatever. Let's think about what's changing here. Okay. What's actually changing is both the east distance and the north distance and the distance apart. All three of those are changing. In fact, it says that the east rate, so E prime, is 600. And it says the north rate is 750. And it's wondering their distance after 2 hours. The rate at which their distance is coming apart. So it's wondering D prime. Well, the formula I'm going to use is the Pythagorean theorem. N squared plus E squared is D squared. And if we take the derivative with respect to time of n squared plus e squared is equal to d squared, we get 2n n prime plus 2e e prime is equal to 2d d prime. So we got some things to fill in there. We've got 2 times n, whatever n is, times n prime, which is 750, plus 2 times e, which we don't know, times e prime, which is 600, is equal to 2 times d, which we don't know, times d prime. So we need to figure out those missing pieces. What is n, and what is e, and what is d? Well, it says that they've been going for 2 hours. If they've been traveling north for 2 hours at 750 miles an hour, then they've traveled 1,500 miles. They've been traveling east for 2 hours at 600 miles an hour, then that's 1,200 miles per hour, or 1,200 miles that they've traveled. So this is 1,500, and this is 1,200. Well, if you know n is 1,500 and you know e is 1,200, then you should be able to figure out d using the Pythagorean theorem. 1,500 squared plus 1,200 squared. I take the square root of the answer, and I get 1920.93. All right, let's compute it. 2 times 1,500 times 750 plus 2 times 1,200 times 600. I will divide that by 2, and I will divide that by 1920.93, and I get d prime is equal to 960.47 miles per hour. The next one's very similar. It says a ladder that's 12 feet long is sliding down the side of a building. So we have this building. We'll put a door here. Whatever. It's more of a window, isn't it? I don't care. A couple windows up here and door handle. And then we've got this ladder. It's 12 feet long. That doesn't change. The base of the ladder is moving at a rate of 1 foot per second away from the wall. So 1 foot per second. How fast is the top of the ladder falling when the base of the ladder is 10 feet from the base? So if we think about this, we have this a squared plus b squared is equal to c squared. I think we all recognize that. If we call this bottom part A, is that changing as the ladder is sliding down? Yeah, it is. Is B changing? Yes, it is. Is C changing? No. So we could write A squared plus B squared is equal to 144. We know A is currently 10 and A prime is 1. Let's take the derivative with respect to time. Of A squared plus B squared is equal to 144. The derivative of A squared is 2A A prime. The derivative of B squared is 2B B prime. The derivative of 144 is 0. So I have 2 times 10 times 1 plus 2 times the base prime is equal to 0. So we need to figure out what B is when the bottom is 10. So if I have 10 for A, I have to figure out B. So let's plug that in. 144 minus 10 squared. And I get 44. So B is the square root of 44. So I have 2 roots of 44. B prime is equal to negative 20 when you add that over. So we're going to take negative 20. We're divided by 2. And we're going to divide it by the square root of 44. And we get B prime is equal to negative 1.51 feet per second. That's how fast that's falling down the wall. Notice how it came out negative because it's decreasing. It's kind of nice. One more. Street light is mounted at the top of a 20-foot tall pole. A man at 5 feet tall walks away from the pole with a speed of 4 feet per second. Got a man, he's 5 feet tall. He's walking this way at 4 feet per second. How fast is the tip of his shadow? So he's got a shadow out here. Call it S for shadow. When he's moving at 30 feet from the pole. So let's think about what's changing. Is the 20 changing? No. Is the 30 changing? Yes. We'll call that D to give it a variable so we see it's changing. Is his height changing? No. Is the length of his shadow changing? Yes. We need to come up with a relationship here that's going to put all these together. And if you can't see it, we are looking at similar triangles. Remember that if triangles are similar, then their sides are proportional. So you've got that triangle, and then you've got the green triangle. So in other words, 5 over S is equal to 20 over D plus S. If we cross multiply, we get 5D plus 5S is equal to 20S, or 5D is equal to 15S, or D is equal to 3S. That's a nice little formula. Let's take the derivative with respect to time. Of D equals 3S. The derivative of D is D prime. And the derivative of S is S prime, so 3S prime. Well, what is the rate at which he is walking away? That'll be 4 is equal to 3S prime. Divide by 3 and we get 4/3 is equal to S prime. So his shadow is moving away from him at a speed of 4/3. But he's also moving. So look at the question. It says, how fast is the tip of shadow moving when he is 4 feet from the pole? So from him, it's moving 4/3 feet per second. But from the the pole, it's moving at 4 plus 4/3 because he's moving as well. So it's moving at 4/3 feet per second from him, but from the pole, it's moving at 4 and 4/3, or in other words, you have what, 5.33 feet per second. See, it's kind of like an escalator. You know, you're at the airplane, and somebody's on an escalator, and if the person's just standing on the escalator as it's kind of walking, um, they're just standing there, and the escalator is moving at a speed of say 3 feet per second. Then how fast is this dude moving? Well, he's moving at 3 feet per second, but relative to the escalator, he's not moving at all, right? So all of a sudden, if we give him some speed, say he's moving at a speed of 2 feet per second, well, relative to the escalator, he's moving at 2 feet, but relative to the world, he's moving at 5 feet per second. So that's what you have to consider in this situation. Normally, I kind of walk around the classroom, give that demonstration for you guys, but remember, that's just 4/3 is how it's moving from him, and then he's moving at a speed of 4 feet per second away from the lamp pole. So yeah, you can see how confusing some of these problems can get. So if we need to Google Meet, talk about it, so be it, but some good stuff. We'll talk to you later. Bye.